Hi, welcome to the Data Science and Machine Learning's Essentials course. I'm Steve Elston.
And I'm Cynthia Rudin. So the chapter outline for the very first chapter is that we'll tell you a little bit about ourselves. We'll introduce data science, predictive versus prescriptive data science, and how to get the most from this course. So I am an associate professor of statistics at MIT. My core expertise is in machine learning and data mining, and I lead the prediction analysis lab at MIT. My PhD is in applied and computational mathematics from Princeton, and I have a lot of experience in data science projects in the electric power industry, healthcare, and in computational criminology.
And I'm Steve Elston. I'm co-founder and principal consultant of Quantia Analytics, and I have several decades experience building analytic models and working with machine learning. I'm a long-term R and before that S user going back several decades. And I've most recently for the last year and a half been an advisor to Microsoft on the Azure machine learning platform, which I'm very excited about. I should also mention that I've been for quite a while now using Python and the Pandas package and been very happy with those as well. So we'll be talking about all those technologies. And I have experience in several industries, payments, telecoms, capital markets, and logistics, say forecasting. And I have a PhD also from Princeton University.
Right. So what is data science? Data science is an evolving subject. It's fairly recent, so there's no single definition. But what we do know is that it requires a range of skills. So yes, computer science, mathematics, and statistics, but also whatever domain you're in, you need expertise in that domain. So for instance, if you're working on a data science project in marketing, you need marketing expertise. And if you are working on a data science project in some other field, you need the expertise from that field, like criminology or whatever it is. We have a definition here for data science that you're welcome to use if you like, which is that data science is the exploration and quantitative analysis of all available structured and unstructured data to develop understanding, extract knowledge, and formulate actionable results.
So let's talk a little bit about what that means. On the left of this diagram, we have this big gray bar marked data. And on the right, we have a big green bar called decisions. And what we need to do is get from our data to some decisions about what actions to take. So across the bottom, these blue arrows show sort of an old-fashioned way this worked. We would look retrospectively, maybe in a BI tool or with some spreadsheet analysis at what happened. And then through a manual process, we'd consider various possible scenarios for decision, perhaps, and then finally come up with a course of action. We got a little better at this over time. We started looking more at root cause analysis, say, and there's a long tradition of that, especially in certain engineering disciplines. Like if you look at transportation accidents, there's always a root cause investigation if a plane crashes, for example, or a train accident, something like that. That may lead through some manual analysis to some recommendations on which is the decision to make recommendations to, say, change a procedure for maintenance or how the plane or train is operated, something like that. Most of this course we're going to focus on predictive analytics, and predictive analytics tell us what will happen. It gives us some ideas about some forecasts for the future, and that narrows down the range of manual decision making we need to make. So you see each of these steps are light blue arrow there, which is the manual part, is getting a little shorter. And where are we trying to go as an industry? We'd really like to go from the data to even an action automatically. There are some decision support type systems and algorithms that help you get to some decision options, maybe a best course of action. And there's there are cases where we're now doing automatic decision support. Classic examples right now are, say, high-frequency trading, where based on a sudden news announcement from a company, some trading decisions may be made completely automatically with no human intervention. Other cases, say, where you're bidding on internet ads to try to maximize click-through. A lot of that is done fully automatically. Decision and the action on which ads to bid for and at what price has no human intervention. So let me talk a little bit about data science and data. So as data scientists, we're absolutely obsessed with data. And the first thing we're always doing is, if we have a problem, some set of users or sponsor has brought us a problem that is their business problem that they want to solve, we're looking around for all the possible data sources. What data can we bring to bear on this problem? Then we found a bunch of data sources, kind of like a little treasure hunt of some sort. Now we need to figure out, how do we acquire that data? How do we get it into some system, whether it's into a data warehouse or into something like Azure or machine learning, where we can do something with it? But of course, it's not going to arrive in the shape we had hoped for, so we're going to spend a lot of time in actuality and a lot of time in this course talking about and doing data transformations, data cleaning, reshaping, things like that. Then we have to understand, what are the relationships in the data? What is this data trying to tell us about the problem we're trying to solve? Which of the features or variables actually seem to be useful and which may be completely superfluous and just adding noise to the situation? And finally, we're going to do some predictive modeling primarily, and through that we hope to deliver value back to our customer or our end users, where it, as we saw in those previous slides, it helps them drive decisions, helps them make better decisions that could be of quite a great value in whatever the process is we're trying to improve. So let's talk about some types of analytics. So I've already brushed on this, but we have retrospective analysis. This is primarily BI tools fall into this category, a lot of spreadsheet analysis. To the immediate right of that, you see real-time analytics. That's a growing area where there's a lot of streaming analytics systems, including in the Microsoft Cortana stack and other places. Say Spark Streaming has become a very popular way to address that. And there we're trying to move, again, toward more taking in the data and making quick analysis, possibly quick decisions. We're not going to talk about that too much in this course, just a little bit. And let me just bring in the last bit here. So we're going to mostly focus on predictive analytics, which is the rubric under which most machine learning falls. And our ultimate goal is to come up with services that make intelligent decisions, that provide intelligent options to decision makers, or something like that, depending on what the situation is.
In terms of predictive versus prescriptive analytics, there is a distinct difference between them. So predictive analytics deals with designing statistical models or machine learning models that predict. They're calibrated on past data. They learn from that past data to help them predict the future. And they tell us what we might expect in the future. But that doesn't determine what decision we should make. So that's where prescriptive analytics comes in. So prescriptive analytics would involve taking these predictions and then turning them into actions that we would take, or a policy that we would enact. And that could involve, for instance, solving an optimization problem. Okay, so just to summarize, we talked about what is data science, predictive versus prescriptive analytics, and getting the most from this course. Next up, I'll be talking about the data science process and the theory of machine learning.
And in subsequent modules, I'm going to be taking you through the practical hands-on aspects of data science techniques and technologies, of how we actually take the theory Cynthia is going to present and translate it into actual solutions.
I hope you enjoy it.